Good evening, students. I'll start with the class. In the previous class, we had solved problems based on the homogeneous type. Okay, that was when you have to substitute y by x equals to v. So we should use y is equals to vx, and then dy by dx was equals to v plus x dv by dx. This was one case where we have to substitute y by x equals to v. But we'll use now next type is of the type, and you have to use x upon y equals to of this type. And now we have to use x upon y. So in this, what is the method is put x upon y is equals to v, x is equals to vy. Now in this case, no, this is ulta. Previous we used to differentiate with respect to x. Now this we have to differentiate with respect to y. So how it is going to be? Now dx upon dy it will become, now u into v rule, copy paste this as it is. What is derivative of y with respect to y? It will be 1. Now we don't have to write extra dy by dx because y we are differentiating with respect to y only. If the same letter we differentiate, straight away we write it as 1. But if this was x, this was y, then it would have been dx upon dy. How this here, no? This was x, but this is y, so that's why dx upon dy plus y. Now this we are differentiating, so this will be dv upon dy. We have to differentiate with respect to y. So this will be the substitution now. Dx upon dy is v plus y dv by dy. So we start with the problem. The question is, okay, now suppose this is the question. Now looking at the question itself, you know that it is in the form straight away x upon y. You don't even, if it was given as y by x, it would have been type 1, means of the type y upon x. But now in the question itself, you know it is x upon y. So it is second case. So you have to use x upon y is equals to v. So in order, whenever you use x upon y, what is the substitution? You need dx upon dy. So now you have to arrange the equation in the form of dx upon dy, not dy by dx. Earlier, previous problems, everywhere used to use it as dy by dx. Here the substitution we will need is dx upon dy. So this equation I have to arrange it is in the form of dx upon dy. So first thing I'll take this whole term on the other side. Now there are two options. Either you can take dy by dx or dx upon dy. So I told you, you need dx upon dy. So dy I'll bring this side. This should be single on one side and remaining take on the other side. You can reverse this sign, minus you multiply inside, so this will become ulta. You can open up the bracket, this will be minus, this will be plus. So this I have wrote first, this I have written on the other side. And now we'll do the substitutions. So the moment I have dx upon dy on one side in this, then put x upon y is equals to v. So x upon y is equals to v. So x is equals to vy. Now this is fixed again. Differentiate with respect to y. This you can again by heart. If x upon y, then these are the fixed steps. So this will be dx upon dy is equals to, so mark this as equation 1, v plus y dv by dy. V plus y dv by dy. Now put whatever dx upon dy is this, put it here. And now write equation 1, everything in terms of v and y. X should go now. Write equation 1. It should remain in terms of y and v. X should go. Wherever there is x, you have to use the substitution. X is equals to vy and dx upon these two substitutions we have to use. Or x upon y will be equals to v. Any of this wherever needed. So what is the equation 1? I'll just write it again. The dx upon dy is this is my equation 1. So instead of dx upon dy, I'll put this y plus v plus y dy x upon y is v. Y x we have to also substitute vy. Everything right in terms of v and y. There should not be any x there in the equation 1. So instead of x, I wrote it as vy. Now see, anything is common, y is common, so take out y common. V I'll take on the other side now, this. Now cross multiply. Cross multiply this upon 2 raised to v. Now cross multiply. After cross multiply, now v minus 2v is minus 1v. Minus 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . plus 1 minus 2 is giving you minus 1. Now take v terms on one side, now variable separable method, and y terms on the other side. So this dv is already here, so rest of the terms I have to bring here. Dy will go up, this is 2, e raised to v will go up, this will come down. I'm just taking that common, minus by will go up, this y will come down here, and now I can integrate. And integrate, minus 2 is out. This minus and 2 I kept it out of the integral sign. Now we have to integrate this. If you notice, there is e raised to v involved. So you know that it is mostly substitution type. Whenever there is log, whenever there is e raised to something, mostly they are the substitution type. What you can do is put e raised to v is equals to t. When you differentiate, this will be e raised to v dv, this will be dt. With respect to v, we have to do. So now this whole thing is equals to dt. So when I write the integral back, this will be minus 2. This is equals to dt. We keep this as it is. That v should go on 1 second. Because everything should go. V e raised to v, it should be. This v is not turning out. See, this is t. T log t, it will become otherwise. One second now. Just try. We cannot keep v also in that integral. But if you try to make this as log, suppose I'm just checking out. Log e is equals to t. This will be log t. V will be equals to log t. And again it will become complicated. Something will be there in the question. I must have copied wrong. 1 second. Just check the question. Question is just a minute. Till then, you try this. Start attempting the next one. Second one. And leave some space, okay? And start doing the same substitution. Just try the second one now. Take this whole term on the other side. Express dx upon dy should be equals to something. Take this whole term on the other side. So start solving that till then. At least attempt, huh? Don't sit idle waiting for me to solve. For exam, I will not come and solve your question. At least try to express it in dx upon dy form, and the main substitution at least I will do. Okay, that previous question, huh? I think I by mistake skipped that 2. There was a 2 there, huh? Okay, first we'll just solve this part. Yes. The question was actually this by mistake. Just correct wherever needed. So you'll also, the first one only I'm correcting, huh? 2x e raised to x upon y. There was a 2 here. So wherever there is, it's just take carry on 2. Wherever there is this, no, just write, keep on writing 2. So what you are going to get is dx upon dy will be equals to 2x e raised to x upon y minus y upon 2y e raised to x upon y. So this will be our equation 1. So just correct this. Huh? Wherever there was a term, this everywhere you continue to the other side. Now again we know that do the substitution, put x upon y is equals to v, the same thing. So dx upon dy was what? V plus dv upon dy will be equals to 2 vy e raised to v minus y upon 2 y e raised to v. After substitution, just write 2 there at the side. And now v would go, after you take y common, for you all no need to write this all over again, you just have to add this 2 there. This will be and then dv upon dy will be equals to y 2 v e raised to v. Your y and y will cancel. 2 minus v. And now you have to cross multiply. So that is why things were going wrong. So this everything gets cancelled. So from here, this part you correct now. From this part you cancel and write it again. So what had happened? We had written this by mistake as 1 only, no? So this term was remaining. This should not remain. So while integrating, we had a problem. So this and this will cancel. Now it will be fine. So dv by dy is equals to minus 1 upon 2 e raised to v. Now take e terms on one side. This will go up. 2 is there. And now you integrate. When you integrate, 2 you can keep out. So 2 e raised to v. Integral of e raised to v is e raised to v only. Minus y. There was y dy, no? Just correct this, huh? 1 upon y. At the side there was y. So this will be log of y. So this will be the answer. There's a y here at the side. Y will come down. V terms I took on the other side, y terms I brought this side. And then integrate. So this is the first question answer. Just even a small number, see, it makes a big difference. And then final substitution. 2 e raised to x upon y. If you want, you can write this plus log y is equals to c. This is the answer of the first question. The second one I had given you 1 plus e raised to x upon y dx plus e raised to x upon y 1 minus x upon y dy equals to 0. This is the second one. So quickly we'll take the terms on the other side. 1 plus e raised to x upon y dx is equals to minus e raised to x upon y. Now we have to arrange it in the dx upon dy form because this is x upon y. So dx upon dy, so rest terms will go on the other side. And now till dx, do the method. Put x upon y is equals to v, x is equals to vy. So when you differentiate with respect to y, you will get dx upon dy will be equals to v plus y dv by dy. This is equation 1. So what will equation 1 become? Instead of dx upon dy, we have to put this. Wherever there is x upon y, you have to put v. Again, x upon y is equals to v upon e raised to v. Now take v on the other side. This v, I took it on the other side, it became minus v. Now cross multiply. And open up this bracket also. Minus into minus. Minus v into 1 is minus v. Sorry, the other one. This and this will cancel. Now write it again and then separate out the term. Minus you can take out common. Now integrate it. Oh, before that separate v on one side, y on the other side. So v is here only. Bring this term this side. So from denominator it will come up here. This fellow will go down here. Dy will go here. One by y dy. Y will go down here. And now you integrate. If you see, this is in the form of f dash of x upon f of x. Just check here. What is f of x? E raised to v plus v. And what is this derivative? Derivative of e raised to v is e raised to v only. Derivative of v is 1. So what is there in the numerator? See, this one's derivative is there on top. It's in the form of f dash of x upon f of x. Because derivative of e raised to v is e raised to v. Derivative of v is 1. So e raised, if I write it like this, in the form of this. So you know that integral of f dash of x upon f of x is log of denominator. So everything is in log. Where it is log c. Or I can use log c on this side plus log c. Otherwise everything will go on one side. So it will be log y. Y no, this side I will use. On this side. Because y will keep on the other side. Why? Because every term will come this side. So log c I can keep on one side. This minus I'll take on the other side. So log of e raised to v plus v plus log y. So log c will be equals to, use log of a into log of b formula. This into this. Then log and log will cancel. And then just put a value of v back. Even if by mistake, suppose if you had written log C on this side, no problem. Only thing what it would have been, this would have got C would have come this side over here, and here there would be 1. So that would be the only difference. Even 1 is a constant. Suppose if by mistake you had written log C, so all would have been log of A, log of B, log of C. C would be coming here because C would come here, and this side would be 1. Even that case is correct because even 1 upon C is still a constant only. So they will not cut marks based on which side your C is. Main important thing is this, because even 1 upon C is constant. Okay, 1 upon some pure number will be number 1. That is not a problem. So don't worry about this log C. So these are the only 2 problems mostly which I've seen, which comes with x upon y. Rest all are y by x. Whenever you have x upon y, they specifically you understand looking at the problem itself in that, especially they have x upon y, then you have no other choice, only that substitution. Mostly comes that starting which I've solved now, y by x. These are only like the 2 rare cases. So the main part as per the NCERT portion which says that part I've finished. Okay, the 2 types, variable separable method and the linear type. Sorry, not the linear type, homogeneous type. These are as per the NCERT. This you have to study. These are 100% there. Now the confusion is the remaining parts. See, this is linear type. NCERT portion says this is deleted. But now city and college says they have done this. Okay, the linear type, and 100% if they are done in the college means it's there in the internal test. Now I don't know which all colleges will do what. So up to y'all. Anyways, I'm doing this topic because for me, from my side, I want to give my 100% that I have completed a full portion. Whether you all want to study as per your college convenience or because never know. So that whether you all want to study or not, it's up to you all. Tomorrow you should not say that I did not do only that topic. So I'm going to do this linear type. And then one more is the formation of differential equation. The formation of differential equation, city and college has not done. Pope John College has done that. And I've seen this now. These are there on now. If you pick up any this the Rajhan's preparatory, of the last year with the deleted portion. In the deleted portion, they have put this. The Rajhan's preparatory itself are having these problems. Now, if any suppose teacher goes for board setting paper and just picks up from a Rajhan, suppose, then that might appear. So just not to take a risk. Again, I will explain these problems also. This I'll do in tomorrow's class. So today I'll do linear type. Just few I'll explain because this I'm sure it is not there in the preparatories also. Okay, I've seen that. I've checked the preparatory, but this is there. But just for safety, I'm doing now since your college teachers have done. So once you understand the method, then you can apply for every single problem there. So whatever your college sir does, then study only those questions for internal test point of view. Board exams it might not appear. I'm saying, yes. Now since other colleges have not done that chapter yet, so just attend. Nothing will go at a loss. Later you want to revise, don't revise, up to you. The third type is the linear type. The linear type is a slightly actually difficult one, but still, yes, I'll explain. Dy by dx This always are in this form. dy by dx plus py is equals to q. These are called as linear type. Any differential equation in the form of single dx is a p into y, and this is a constant. And this is considered as a coefficient. Or actually, no, there are some terms also I can say, not necessary. They have to be constant. Again, in terms of x, it could be. This also will be in terms of x. P and Q will be something in terms of x, or it could be a pure constant also. But dy by dx and this y has to be fixed. Directly, I will start with the problem. Or before that, just one thing, something called as integrating factor you will have to find, which is called as IF. And IF formula is given as e raised to integral of p dx. You have to integrate this p. E raised to integral of p with respect to x, because this coefficient will be in terms of x. So obviously, you have to integrate with respect to x. Okay, this is the formula for integrating factor. So I'll start with the first problem straight away. I have to solve this. dy by dx plus 3y is equals to e raised to minus 3x. If you compare with this, obviously it is in the proper form. So p is 3 and q is e raised to minus 3x. Just compare with this. Okay. Now, what you have to do is, we have to find the integrating factor. P is 3. Integral you keep out and this number. So what is integral of 1 with respect to x? It is the integral factor is e raised to 3x. You have to take integral of p. E raised to integral of whatever is there. So integral of 3 is 3x. No writing plus c and all, just normal integral. Mark this as equation 1. Okay. Next step is to multiply equation 1 by integrating factor. The whole equation you have to multiply by this integrating factor. So what you're going to get is e raised to 3x dy by dx 3 e raised to 3x into y. All the terms you multiply. This first term also will get multiplied e raised to 3x. Here also e raised to 3x. Here also e raised to 3. So every equation I have multiplied by integrating factor. Till this part, if anyone having doubt, you can ask. First, I've just compared this with the main equation. So I got the value of p. So this is a fixed formula. Integrating factor is e raised to that. So I found this, multiplied throughout by this integrating factor. Now one specialty is that this side term will always be a formula of u into v. Just see this now. It will always be derivative of this into, just take what is derivative of e raised to 3x into y. Just check. I just want to find, suppose this integrating factor is there, no, into y. Any integrating factor into y, you just find a derivative of that and see what you will get. This is u into v root. So derivative of this into this is u. We copy paste as it is. What is derivative of y with respect to x? dy by dx plus y into derivative of e raised to x. Derivative of e raised to x is e raised to x only into 3. If you see, isn't it the same thing? It is put 2 in 3 in equation 2. Instead of this, I have to put it here. So what is equation 2 going to become? Instead of this, I'm putting this here because this is same as this. So d by dx of e raised to 3x into y. And what is there on the right hand side? E raised to 3x. And this will cancel out each other because e raised to 3x is always 1 upon e raised to 3. That will cancel. Plus and minus will always cancel out each other and you'll get 1. So d by dx of e raised to x is equals to 1. And now integrate. Okay, integrate both the sides. Or straight away, what you can do, instead of integrating, the moment I remove d by dx sign from this side, no, it will become an integral on the other side. Oh, no problem, you can say integrate. Integral of a derivative is always cancels out. So if you take integral, it will cancel out. So what remains is only this part, e raised to 3x into y, and here there will be an integral. This dx will go up. An integral of derivative always cancels out. It will look like this. Now when you integrate, derivative and integral will cancel and you will get integral of 1d. So basically this goes straight away and becomes integral of the other side. And what is integral of 1? Nothing but x plus, that is the answer. Now one more I will solve, so you will get any doubt, then you can see, you can understand the second one. I have told you dy by dx plus p y is equals to q. So dy by dx should be single. There should not be anything there here. I have to arrange it in this form. So I don't want this x at the side. Here x is extra. So what I'll have to do is multiplication. So I have to divide throughout by x. First, arrange it in this form. So dy by dx will be, we will get like this. So dy by dx will be equals to 2 upon x. Now compare it with this. So value of p is what? 2 upon x. Whatever is coefficient of y is p. Okay. And whatever is here, q is anyways y. Sorry, x. Now we'll find the integrating factor. Basically, we don't need actually q. Main is to find p only. Because integrating factor is e raised to integral of pd. The integral of 2 upon x dx. So we have to integrate 2 upon x. So 2 you bring out of the integral sign. This will be 2 log x. Integral of 1 by x is log x. You can still simplify this. This you can take as log of x square. It will become power whenever you take inside. And e and log always cancels out. I've told you before also. Anything is there, no? As long as there's no coefficient, there should not be anything in the middle. You directly can't cancel this e and log because 2 is there in the middle. So 2 I took inside first, and e and log always cancels out each other. So this will be x square. The integrating factor is x square. Now multiply equation 1. Multiply equation 1 by integrating factor. Multiply throughout equation 1. So everything will get multiplied. All the terms will get multiplied of equation 1 by x square. Now simplify. Next you have to always, I told you, find, just always check the derivative of integrating factor into y. Always try to take derivative of integrating factor into y. What is the integrating factor? X square. You will just try to find out what is derivative of integrating factor into y. So this is u into v rule. Mark this as equation 2. U into v is what? U into derivative of v. I'm applying u into v plus. So you just see, isn't it the same thing? This is nothing but x square dy by dx plus 2x. This one. So put 3 in equation 2. So instead of this, I have to substitute here because this and this is same. So this thing is nothing but derivative of x square into y, u into v root. So if you solve this, we'll get this. This I'll write What is the right hand side? X cube. Now you integrate. Before that, you can take dx on the other side. Integrate now. So when you integrate, derivative and integral will cancel. Now integrate. Integrate on the right hand side. The integral of x cube is x raised to 4 upon 4. This is the answer. Third one. dy by dx plus sec of x into y is equals to 10 of x. Now this is straight away in the form of linear equation. This is dy by dx plus py is equals to q. So p is nothing but sec of x. Mark this as equation 1. P is sec of x. Now we'll find integrating factor. Integrating factor formula is integral of sec of x is log sec x plus 10x. This is the integrating factor. E and log will cancel. Now multiply equation 1 by the integrating factor. So throughout, have to multiply. This is what you will get after multiplying throughout. So just multiply this inside one time, like x plus 10x dy by dx will be equals to, multiply inside, it will become sec square x plus sec x 10x, y you keep out only, is equals to, no y, no, there was 10x, sorry, . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . 10x it is there. Now you see, try to take derivative of integrating factor into y. What I told you, once you get equation 2, this is equation 2, try to take factor of derivative of integrating factor into y. What is the integrating factor? This. I just want to check what is derivative of. So this is u and this is v. Integrating factor into y. So sec x plus 10x u into derivative of v plus v means we copy paste as it is. Now derivative of sec x is what? Sec x 10x and derivative of 10 of x is x square x. So it's the same thing. Always you don't even have to think. Even if you forget no what is derivative of this into this, just copy paste this as it is. This will always be here. Even if you forget what is all this derivative, just later write derivative of integrating factor into y. So you know integrating factor is this into y. We can actually completely skip that second equation also and you can directly write here because we know that equation 3 is always same as equation 2. So these two steps can be skipped. What? Which one? This one. Okay, after multiplying by the integrating factor, you can just get this. This step you can skip and straight away you know that here always derivative of integrating factor into y will come for sure. So you know what is the integrating factor. And this side whatever is there. Sec x and now integrate. This will go on top. This will always cancel. And multiply this inside. 10x into 10x is 10 square x. Yeah. This side no need to integrate because it's already got cancelled. Integral of sec x 10x is, before integrating you know that this is the integral of sec x 10x is sec of x. This is a straight formula. But this is a square of a trigonometric function. So there is no direct formula for 10 square x. So I have to first express it as x square x minus 1. 10 square x is nothing but x square x minus 1. I always, this exists. Integral of x square x I know. But 10 square x is not there. So I have to convert it in this form and now integrate. Integral of sec x 10x is sec of x. Integral of sec square x is 10x. Integral of 1 is x. That's the answer. Both 1. Is equals to 1. And this is dx upon dy. So I'll just arrange it in dy by dx form. So this I'll take on top, this I'll bring this side. This term I'll take it on the other side. So just write this term this side, this that side. So it means the same. Whether I write A equals to B or B equals to A, it is same. So this I'm writing this side. So what is the coefficient of y? I'll separate it out and write y upon root x is nothing but 1 upon root x into y. So compare it now. P is nothing but 1 upon root x. Whatever is coefficient of y is P. Find the integrating factor now. Integral of 1 upon root x is 2 root x. This straight away direct formula. Integral of 1 upon root x is 2 root x. The integrating factor is e raised to 2 root x. To multiply, this is equation 1. Before finding integrating factor, whatever is the equation, that's the equation 1. To multiply equation 1 by integrating factor. So the whole thing. So this is what you will get after multiplying by the integrating factor. Now remember, I told you, you don't even have to do that. Try to take the derivative. In case if you're finding that difficult, no, straight away, you know that always this will be equals to straight away, huh? Not writing equation 2, equation 3, straight away you can write this as this anyhow will end up as d by dx of integrating factor into y. Always. So you can just remember this, directly substitute. This is always integrate. If you split this, you will always get this. So integrating factor was what? Sorry, e raised to 2x. Same thing on this. This will always cancel out each other because this is always equals to 1. If we add this powers, if we add, we'll get 0. E raised to 0 is always 1. Why? If there's same power, plus and minus can straight away cancel, provided as a multiplication sign. Now you integrate. When you integrate, you know that derivative will cancel. Dx will go this side. Derivative and integral cancels out. So this side you don't have to integrate. Integral of 1 upon 2 root x is 2 root x. That is the answer. And last one I'll do this. 5 problems I've solved, okay? Because I don't feel so according to me. It's there in the NCRT. Now your teachers are doing, so that much I can do. I've explained you how to follow the method. Once you understand the method, you know that now everything depends on the integration formula. You should know integration. So that's the same thing. The first step is to arrange it in the linear type form, find the integrating factor, multiply equation 1 by integrating factor, then just express that as d by dx of integrating factor into y, then integrate. So now whichever problems your college teachers are doing, take those problems, try to solve. One second, I took the wrong one. 1 plus x square dy by dx plus y is equals to e raised to 10 inverse of x. Now you know that it should be in the form of dy by dx plus py equals to q. Now sum of something is there. This should be alone. Dy by dx should be alone. No coefficient should be there. So what I'll have to do, I'll have to divide it. Divide throughout by 1 plus x square. So everything if I do divide, you will get an equation like this. Basically it's y upon 1 plus x square. I just splitted it and wrote like this because I want to write it in p into y. Y I want to keep single. So y upon 1 plus x square can be splitted as this into this. Even this will get divided. Now p value is 1 plus x square. Sorry, 1 upon 1 plus x. Whatever is coefficient is p. So find the integrating factor now. You know what is integral of 1 upon 1 plus x square? It is 10 inverse of x. So integrating factor is e raised to 10 inverse of x. Multiply equation 1 by the integrating factor. So the entire equation will get multiplied by integrating factor. And now you know that after that it should always end up as derivative of integrating factor into y. So derivative of integrating factor is how much? E raised to tan inverse of x into y, whatever is here this side. Now common I'll write tan inverse into this plus tan inverse. It's common, no? Powers will get added, so it will become 2 tan inverse. Now integrate. Dx I'll take on the other side. This and this will cancel. Now I have to integrate this. So we'll have to use substitution method. You can put tan inverse x equals to t. So when you differentiate, you know that 1 upon 1 plus x square dx will be equals to dt. Here, this is function 1 upon 1 plus x. So dx upon 1 plus x square equals to dt. When I write the integral back, this dx upon 1 plus x square is dt. And this is how much? You can put e raised to 2, this, what is that? 2 tan inverse of x also equals to t. Huh? Accordingly, then what you'll get? You'll get dt upon 2. You'll have to balance it with 2 there. Okay, you can straight away, you know that tan inverse of x is t. Its derivative is this. So dx upon 1 plus x square is nothing but dt. When you write an integral back, this is how you will get. I just integrate e raised to 2t. Integral of e raised to this only, but now the coefficient of t is 2. So while integrating, we have to divide by 2. That's the same thing. If I use 2 here now, you would get dt by 2. So this is the answer. So just replace t. So that is the answer. Okay, there are many problems you can solve. One, there it will be there in the older preparatories or the question papers which I've sent. Okay, so I'll stop here. Only formation of differential equations are left that I'll finish tomorrow. Tomorrow I'll finish with the chapter. Actually, I was supposed to finish today, but now since I noticed that the formation of differential equations are there, I'll do that.